Okay, cool. Let's get started. So thanks for having me. It's a pleasure to be here. It's one of the first conferences of the pandemic I'm visiting. And yeah, this is about module federation, about micro-frontends, a topic a lot of companies are discussing nowadays. And I'm quite sure you have already heard about this topic. At the end of the day, it's similar as with microservices. It's all about decomposing a huge application into tiny parts that are developed by separate teams. Teams that can work in a more or less autonomous way. That means they don't need to talk with each other, at least not too much, and they can do their own decisions. And the best is they can provide business value on a regular basis. When they are done, they are just pressing a button and deploying it. To put it in another way, this all is about getting back the agility of small teams, even though we have a huge overall software system. And I think this really shows that first and foremost, this idea of micro-frontends is about scaling teams. It's not that much about technical aspects. Of course, there are some technical reasons for doing this, but first and foremost, it's about scaling teams. And a good friend of mine told me, well, Manfred, you know, teams is plural. That means you need to have more than one, otherwise it might not make sense. And yes, he was totally right. If you only have one team, then you should really think twice, or perhaps 3 times, 4 times, if you really need those micro-frontends, because they come with some costs. They come with some costs, and if you don't need it, then you might not want to pay those costs. By the way, there is one issue, namely this guy here, your customer. The guy with the little tiny sheets of paper with little numbers on it and bridges in our case, in the case of euros. I really love those bridges. And this customer is not interested at all into micro-frontends. No, not at all. Everything the customer wants to have is one application that is capable of doing everything they need. And that means we need to integrate everything at runtime into one thing, into one application. This really needs to happen at runtime because we don't know those moving parts at compilation time. They are developed separately. They are compiled separately. They are deployed separately. So we only know them, or at least the newest version of them, at runtime. And runtime integration is hard. Runtime integration is really difficult. Of course, there are several tricks out there we are using for decades. For instance, several years ago, a lot of people used, iframes. I don't want to speak out this word that loudly, but yeah, this was what people did to integrate several things. And yeah, it works, but of course, it has several differences. Difficulties, disadvantages. Also, some people started experimenting with web components. They tried to load web components on demand. It's also possible, but you need to tinker a lot of infrastructure code. You need to create a lot of code that is quite difficult to maintain. The good message is, with Webpack 5 module federation, we have a rock-solid, straightforward solution for runtime integration. It's really as simple as that. At least in theory, it's as simple as that. You can import something from over there. You can import a component, a function, a module from over there, from a separately compiled and deployed micro-frontend. So in theory, it's really easy. However, in practice, if you get started with this, if you implement an application with this approach, then several advanced questions will come up. Questions like, how shall we deal with version mismatches? Because for sure there will be version mismatches, and somehow you have to deal with them. Perhaps one micro-frontend is using this version, another micro-frontend is using that version, and you want to prevent that everything blows up when they are integrated in one browser window. Another advanced topic is the big question, shall we go with a monorepo or shall we go with several repositories? Or dynamic federation, what happens if we don't even know the number of those micro-frontends up front? And last but not least, can we combine multiple frameworks and framework versions? Is that possible? What happens if someone is using React and the other group is using Angular? What happens if we have Angular this version here and Angular that version there? This is all I will tell you today. I will talk about those advanced topics and about solutions in the area of module federation. Plus, to get everyone into the boat, I will start with a little tiny primer into module federation. It's not much, it's just about 3 slides, but I really want to get everyone here into the boat. Before we start, let me also introduce myself. I am Manfred. I'm a trainer and consultant for Angular, and I'm focusing on Angular for enterprise-scale applications. In this role, I'm doing a lot of consultancy, and I'm also doing a lot of workshops. Besides this, I'm also quite connected to the Angular community. I live here in Austria, to be more precise, in Graz, and I do a lot of stuff in Germany. Normally, I'm every second week in Germany helping companies there with Angular in the enterprise. And of course, I'm always happy to work together with people around the world. Nowadays, we can also use remote technologies. I think we've learned that in the last years, so it's easier than ever. Okay, let's get started with module federation. Let's get started with the basics, just a little tiny primer. So, in order to make it possible to load something from another application, we need 2 roles of application. The first role is the shell. The official term is the host. In our case, it's the micro-frontend shell. And the second application role is the micro-frontend. The official term is the remote, because it exists somewhere over there remotely, you know. And then you can configure both. You can start with configuring URLs. You can say, well, I want to map this URL, mfe1, to this micro-frontend over there. Here you have the URL. That means every time you are going with this very URL, Webpack will grab something from over there, a module, a component, or perhaps just a function. And over there, we can expose files. Exposed files can be loaded into the host, into shells. And of course, the shell, the host, is not interested into your folder structure. They are not interested into the fact that this very file is located in x/y/z/ I don't know, my component, yes. No, they are not interested. And that's why normally you are mapping those paths to short, pretty names like CMB, like here. And then something beautiful happens. I guarantee you, you will love it. Then all you need is just a dynamic import. All you need is just a dynamic import using the map names. And this allows you to grab over there to load something from a different application. And this is really beautiful because of this Angular or your very own high-level framework does not even recognize that we are working with micro-frontends, that we are working with separately compiled and deployed stuff. And that means you can use your framework, in my case it's Angular, as is, as it was intended to be used. You don't need to tweak it, you don't need to go with any dirty workarounds, no, just use it as is and Bob's your uncle. How cool is that? This was really quite a burden in the past. Implementing all those workarounds for synchronizing different web components or iframes was really a burden. I've talked with several customers. This was the biggest challenge, but now everything happens underneath the covers. Another nice feature of module federation is you can share libraries. You can say, well, I have Angular here, you have Angular there, so just let's load it once. It does not make sense to load Angular 10 times just because of having 10 micro-frontends. Would be quite an overhead, wouldn't it? Of course, when we talk about sharing libraries at runtime, then something comes into mind, namely DLL hell, the good old DLL hell we know from the good old Windows times, where we have 2 or more different applications reusing the same library, but unfortunately in different versions. This is one of the aspects I will talk about today. But before we move over to talking about version mismatches, about DLL hell 2.0, let's talk about how to use all of this with Angular and the Angular CLI. In the world of Angular, you know, everything is a bit abstracted. Everything is abstracted away. For instance, they have Webpack, but it's hidden behind a layer of abstraction or several layers of abstraction. And that's why you need a plugin. That's why you need a plugin. I've written such a plugin, just ng-edit, adjust the generated Webpack configuration. This ng-add gives you the skeleton of a configuration you can extend, and then serve it, and hopefully everything works. If you use another framework, just skip this slide. If you use another framework, just configure Webpack, as you will see on the following slides. Okay, let me show you a demonstration for this. So in this demonstration, I have here a simple shell. Here I have a micro-frontend. It's within those dashed red lines. And if you click here to flights, then hey, it's directly loaded into the middle of my single page application, into the middle of my shell. It's directly loaded in here, even though it comes from a different application. To prove that, I'm going with different boards. And no, this is not a prerequisite, not at all. But having different boards really proves that we are talking about different applications that are integrated at runtime. Here, for instance, we have localhost 3000. Here we have localhost 5000. Let's have a look at the network tab. Check. Let's click here. And here you see it really looks like lazy loading from Angular's perspective. However, the main difference is we did not know it at runtime. Plus, this here is quite slim, isn't it? 9.7K is everything but much, especially in the world of Angular. And I think that proves that we are sharing Angular at runtime. If you are wondering, hey, what is this huge file here, the remote entry with 200 Ks, it's metadata. It's metadata that's also loaded so that the shell knows about this or that available micro-frontend. However, this metadata is only huge in debug mode. In production mode, it's really tiny. In production mode, it's somehow ridiculous. We just talk about 3 or 4 Ks. Here it's 200 and something Ks for some reason. Okay, so we have both. We can integrate stuff and we can share libraries. Now let's come to the first advanced topic. Let's talk about version mismatches. And when it comes to version mismatches, I really like to tell a little tiny story. I'm not sure if you knew it, but Webpack is German. Webpack is mainly developed in Bavaria, in the north of Bavaria, but never call it north of Bavaria, it's Franconia. It's developed there in Franconia in a little town. No, it's a city. It's a city called Fürth. It's a city in not far away from Nuremberg. And there is a nice, very smart guy called Tobias. And Tobias implemented Webpack as a byproduct of his master thesis several years ago. He wrote a master thesis about a web application, and somehow he needed a good bundler. And he didn't find one, so he implemented one by himself. And this became Webpack, this de facto standard that is used out there in all the communities, in the React community, in the Vue community. Of course, sometimes we have alternatives in Vue, but also in the Angular community, Svelte, and so on. And Tobias already had a first version of Module Federation. It was before the pandemic. And he saw it and it was good. But then he talked with companies about this implementation. And they, of course, told him, hey, DLL hell, we need to prevent it. And that's why during the beta phase, Tobias completely rewrote Webpack from the scratch. He rewrote Webpack, Module Federation, from the scratch, to be more precise, to bake in this very topic in its DNA. And the result of this is really amazing. The result of this is that even the default behavior is quite smart. The default behavior is that we get the highest compatible version by default. The highest compatible version, which is quite an awkward term, but it means normally the highest minor version. So let's assume one Micro-Frontend has version 10, the other one has version 10.1. A higher minor version should be backwards compatible, at least according to semantic versioning. And yeah, so let's go with 10.1, let's keep 10, only 10.1 is loaded. Should work if we align with the principles of semantic versioning. However, there are situations where we don't have a thing like a highest compatible version. For instance, let's imagine we have version 11 here and version 10.1 here, there. And then there is not such a thing as a highest compatible version. So what to do? Well, by default, now Module Federation loads both. By default, it loads both into the browser, which is for sure a hit on the bundle size. But sometimes bundle size is not the most important criteria, especially if we talk about enterprise software, software used in-house behind a firewall. Then it's not the most important criteria. Then additional some 100Ks is okay-ish, I guess. It's not beautiful, but it's okay-ish. However, if we start here with loading Angular itself or React or Vue itself in different versions, if we talk about your main leading framework, then this might become an issue. Because those frameworks have not been tested if they run with another version of itself in the same browser window. It's not supported. And sometimes there might be an issue you need to tackle with some workarounds. However, if this is just about libraries like underscore, it's really not a big deal. This application here is not concerned if that Micro-Frontend there is using a different version of underscore. So that should work. But beware mixing different leading frameworks, frameworks that think that the browser window belongs to them, like Angular, React, and so on. It's possible, but it's quite a rocky road, so try to avoid it. There are several other options for configuring your dependencies in order to deal with version mismatches. For instance, you could say, well, let's apply the singleton principle. In this case, we can only have one version of our dependency. So one more time, let's assume there is a version mismatch. The first Micro-Frontend is going with version 11, the other one is going with version 10.1. And now we have a conflict, and because of this, only version 11 is loaded. We've configured it as a singleton. There can be only one version. There can be only one, the Highlander principle, if you ask me. And of course, this might end in a disaster, because no one guarantees that version 11 is backwards compatible to 10.1. If you have a good luck, then yeah, everything is fine, but no guarantees. Don't blame Webpack if this fails. Well, the good thing is, here we're getting at least a warning. A warning on the console, on the JavaScript console at runtime, telling us, are you sure? Manfred, are you sure that you know what you are doing? This might fail. If you don't want to have a warning, but a slap into your face, and sometimes this is really the better approach, then go with strict version true. In this case, you are greeted with a runtime exception when the application starts up. And I really love this. I really love this because this makes my integration tests fail fast. We see immediately, hey, there is an issue, we need to deal with it. And this is normally what I want. I want to make it easy for my integration tests to warn me, to prevent me from a disaster. You can even relax the required versions. You can say, well, I know it's compiled against version 10, but hey, I'm an expert. I know what I'm doing. It will work with everything between version 1 and 11. One more time, you are taking the responsibility. However, don't blame Angular, don't blame Webpack if this will not work. So to recap, there are several baked-in options for dealing with version mismatches. And as you have seen, they are actually quite smart. However, if you ask me, the best option to deal with version mismatches is to make sure they never occur, to avoid them upfront. And this directly brings me to the second topic I've prepared. It's the topic about monorepos versus multiple repos. The big question, and somehow there is a lot of emotion in this, is shall we use a monorepo or shall we use multiple repositories? And the answer is yes. You should use a monorepo or multiple repositories. Both works. I've seen both working out there in the wild, however, both has completely different consequences. So let's get started with what I'm calling micro-frontends by the book. If you use micro-frontends by the book in a way they have been intended originally, then you would go with multiple repositories. The main advantage here is you have strict borders. Strict borders, the borders of your repositories. And that means within your borders, you can do what you want. You can do your own decisions. You can choose this framework or that framework. You can go with this architectural style or that architectural style. However, this maximum amount of freedom comes with costs. It's not for free. One cost point is now you need to share your shared libraries via NPM again. That means you need to version them, you need to publish them. You need to install them everywhere. You will find out, hey, there is a bug in here, and so you need to fix the bug, increase the version number, publish it again, install it again, and then you find out, hey, there is another bug. And this goes back and forth, perhaps you know this, until you are done or crazy, depending upon what happens first. Okay, we can tackle this somehow with automation, but it's not that funny. Another disadvantage is you can do what you want, and so you will end up with version mismatches, because perhaps you have Angular 11 here and Angular 12 there, or Angular here and React there. And the main difference to microservices is such a micro-frontend in a single-page application world is downloaded. It's downloaded into your browser. That means you will download several versions of the same framework or different frameworks, and then you have a version conflict there. And obviously, having version conflicts in a browser is not that great. I think the browser is not the best place for having a version conflict. Okay, there is no perfect place for having version conflicts, but the browser is one of the worst places, if you ask me. So better prevent this. And yeah, as mentioned before, this is really one of the main differences if we compare this with microservices, because a microservice is never downloaded. It sits there behind its URL, and I'm not interested into how this microservice was written, with which technology, with which version. Is it written with Spring Boot, or did someone tinker its very own web server with C++? I had a colleague doing something like this. I think he didn't sleep that much because he needed to maintain his own web server. But anyway, if we, however, switch over to a monorepo, we have a one version policy. I'm always saying we are restricting ourselves to one version. However, because we are restricting ourselves in the first place, we don't have issues with version conflicts and bundle sizes later. You know, with great power comes great responsibility. Here we try to limit our power to have less issues. However, one question that arises now is how to avoid coupling. Because if everything is in one monorepo, everything will be coupled for sure. Someone will create an import pointing over to another business domain and so on and so forth, and then everything is intermingled. Then we have cable spaghetti like here. So how to avoid this? Well, I have a good message for you. You don't need separate repositories to avoid this. You can totally go with linting. There are linting rules available for ECMAScript and very likely for other languages, allowing you to define rules. Rules like source code in this area is not allowed to access source code in that area. This is what I'm doing here. Here I'm within my domain. You see it here, boarding. It's about flights. I'm in the boarding domain. And yeah, I try to grab over to my booking domain. I try to reuse something from over there, and I'm not allowed to do this because it's a different domain and we want to decouple things. And this linting rule is telling me, hey, Manfred, what do you try to do? What do you think where we are? That's not allowed. It's not allowed to use something in the domain booking. You are only allowed to use something in the boarding domain and something that is called shared, which is the shared part of our system with several technical libraries, you know, authentication and so on. If you want to have a linting rule like this, look into NX. It's really a beautiful framework. It's actually more than a framework. I would not call it a framework. It's a built environment for monorepos, and it provides a lot of stuff very usable, sometimes needed, for enterprise-scale monorepos. So really look it up. It works with all the technologies out there, Angular, React, Vue, and so on and so forth. Yeah, here we have it. So let's move over to the third topic I've prepared for you. It's about very dynamic module federation. Situations where we don't even know the number of the micro-frontends up front. How can we deal with such situations? Well, we have seen before, normally we are mapping our micro-frontends to URLs. This happens here on the left side, where I'm saying MFE1, this virtual URL, points over to this or that URL. However, if we don't even know the number of micro-frontends up front, because everything is highly dynamic, we need to get rid of this. We do not know what to map, at least not when compiling the system. And instead, we could now provide this information when importing something from over there, and that's why here I'm switching out import by a helper function called load remote module. It's just a helper function talking to Webpack at runtime. When you compile something with Webpack, you have some objects in your global namespace at runtime. And I think we all know what I'm meaning when I'm saying global namespace. The good old window object. And yeah, you can tell those objects at runtime, hey, today I have a micro-frontend for you. It's over there, and another one is here. So please load it. And this is what happens here underneath the covers. I'm just passing the key data for loading everything, something I would also pass statically when mapping those micro-frontends in my Webpack configurations. Okay, let me show you a demonstration for this. In this demonstration, I'm moving into my source code. In my case, it's a monorepo, a traditional Angular monorepo. And here we have one application with our shell, which is indeed a traditional Angular application. Nothing special in here, nothing special but a Webpack config. And if we look into this Webpack config, then we see that normally I would map my remotes, my micro-frontends in here to get virtual URLs. But I commanded it out. I commanded it out because I really want to go dynamic. Now let's move over to my routing configuration, to my app routes. And here I've already prepared my dynamic route. You see it's a lazy route. In Angular, always when going with a lazy route, you have a path and you have load children. And load children points to something that is loading the lazy parts of your application. And normally, I would use an import. But as I want to go really dynamic, I moved it, or I exchanged it by a load remote module. And this function gets all the key data for loading this or that micro-frontend. You see the URL of the remote entry of the metadata, the only URL we need, comes from a constant. And I think if we see that it can come from a constant at runtime, we also see that it can come from literally everywhere. We could load it from everywhere at runtime. From a configuration file, we could ask a backend service, hey, what do we have? And it tells us, well, today we have 3, tomorrow we have 5 micro-frontends. So perhaps you say, well, that's nice, but for me this is not dynamic enough. Not good enough for me, because here everything is in our routing configuration. And the routing configuration is more or less static, isn't it? It's compiled into the application, and so it's more or less static. Well, also here we could go fully dynamic. Let's command this out. That means everything that remains is my static routes, my home route, for instance, or an about route. And then let's move over to my app component. Here I have prepared a little something. Here let's assume we are tinkering further routes at runtime during the start of the application using some metadata from the backend. I think we all can imagine to get some metadata from the backend, and using this metadata we are tinkering this routing configuration, or to put it in another way, this array with objects. Because a routing configuration is just an array with objects in Angular. We can totally tinker it by hand. And then let's combine it with the remaining static routes. Let's spread all of them into a new route array, and then let's tell the router, hey router, it's showtime. We have new routes for you. Please respect them. Yeah, and now everything is really dynamic. All the routes pointing to the micro-frontends. Saying this, and perhaps you've seen it here, if you want to avoid issues with deep linking, move this line of code into an app initializer, because it runs before deep linking is executed or is respected. Let's put it that way. Okay, let's try this out. Do this work, or did Manfred just tell you jokes? Schmähs? Yeah, it worked, but now it's dynamic. Now we are deciding at runtime what to load. Okay, cool. I have a last topic for you, and this is really a difficult topic. I call it the Frankenstein architecture. Yeah, this is the Frankenstein. It's not me at college, no, it's the Frankenstein. And you know, this Frankenstein is really difficult to control. We all know the story. It did not turn out that well back then with Dr. Frankenstein at the North Pole at the end of the story. It was a disaster. But if you say, well, I can control this guy, I really need to mix and match multiple frameworks and framework versions, then there are solutions. They are not perfect. The road is quite rocky, the sky is dangerous, but if you really, really need it, if you assess all the advantages and disadvantages, if you look at your architectural goals, and if you say, I need it and I can control it, here is the way of doing it. We have seen before that with module federation, we can load from a different application. A component, a module, a function, more or less everything. So the idea is to go one step further and to not just load one thing from over there, but to load the whole application. Each single page application has a main TS or a main JS or something like this, and just import it. Import it as a whole. That means you get a whole single page application in the middle of your existing single page application we are calling our shell. And then bootstrap it there. Bootstrap it in the middle there. Perhaps we need a root element for this second single page application. Most of those frameworks are looking up an element and mounting them inside of this element. We can tinker this element with 20-year-old DOM magic. And then perhaps you don't even need a bootstrap function or method, because normally single-page applications are self-bootstrapping. And then the next step would be to wrap all of this in a component, in an Angular component, in a React component, in a Vue component, depending upon what you are using for your shell. Because wrapping everything into a component allows you to root over to this or that single page application, to root over to this or that micro-frontend. Are there challenges? Yeah, for sure. There are several challenges, because I've mentioned it in the beginning, most of those frameworks are not intended to be used with other versions of themselves. They think that the browser belongs to them. You know, it's like with Louis XIV, the state am I, the browser am I. Here I would say, well, the framework thinks it is the owner of the whole browser. And so we need several workarounds. Are they pretty? No. But if something is not pretty, we can hide it. Hide it under the carpet. Hide it behind some helper functions. And this is what I did here. Here I have this add-on library, module federation tools. The module federation library is unopinionated. The tools library is very opinionated. Here we have all those 30 workarounds. Yeah, but the good message is, if you go with those workarounds implemented by yourself or by this library, then it will work. And the result is really amazing from an architectural perspective, because now we can mix and match different frameworks, different versions, but even though we mix and match them, we can reuse them if some micro-frontends happen to use the very same version. This is because of module federation. Module federation allows to share, and bootstrapping different frameworks allows to go with different versions. And this is something I want to show you here in the ending. So let's move over to my application. Here I have prepared a little something, a little route. And here we go. So what does this route do? Well, it routes to a component called the web component wrapper. I've wrapped my applications out there in web components. It's not a prerequisite, but wrapping them into web components makes several things easier. You don't need to think about that many things. And then you see it here, there is a data structure called data. So it's really a data structure. And in here, I'm placing the key data I need to load this or that micro-frontend via module federation. Exactly the key data we've seen before when we've talked about dynamic federation. And also, here is the name of the element, of the HTML element we need to create, because this single page application is mounting itself in there. One little tiny add-on. Here I'm not going with a route that is a string. It's commanded out. Instead, I'm going with a matcher. A matcher is just a function looking at the URL and saying yes or no, works or does not work. We need to activate this route. We don't need to activate this route. And you can imagine what starts with is about. It just looks at the beginning of the route. If it starts with React, then we are routing over there. We are not looking at the remaining parts. However, the loaded application might look at those remaining parts because perhaps we have a router in there, a React router inside of the React application, inside of the shell with our own Angular router. Okay, so let's try this out. Surprise, and I'm not online. Yeah, okay, I should be online. So let me quickly try this out. So do we have Wi-Fi here? Let me data. I need to utilize my very expensive contract, you know, a very expensive mobile phone contract. Don't hack me. I trust you. We are all honest people, aren't we? Okay, yeah, look at this. How cool is that? Thank you, thank you. Yeah, it's really nice to load a React application into the middle of an Angular application. However, we could do better. Here I have a demonstration in the cloud. And yeah, first of all, I'm loading my shell. As you see here, it's using Angular 12. Here I'm using a first Micro-Frontend. It is also using Angular 12, so no big deal. Here I'm loading a React application. Here I'm loading another Angular application. However, here we are going with 12.03, a different version. That means we need to download this different version. However, we only need to download it once, because we can reuse it across all the other applications also going with Angular 12.03, like here or there. And here we even have a router inside of this single page application, of this micro-frontend. Here we have a view application. In my point of view, this really shows we can mix and match different technologies. And here we have AngularJS. And I think this shows that this architecture is a nice way to migrate away from a tech stack little by little. Perhaps this is one of the use cases for a Frankenstein architecture, migrating away from an existing tech stack little by little. Of course, if you can avoid it, don't do it. That's what I'm always saying. Don't do it if you can avoid it. But yeah, you cannot rewrite a whole system from the one day to the other day, so could be a nice migration strategy. And this is here the example from hell. All the frameworks on one page. So if somehow possible, also avoid this. If you need it, just do it on a route base. Okay, cool. So if you like this presentation, there is much more in my free ebook. Meanwhile, we have 120 pages and it's still growing. You can download it for free here. And if you did not like this talk, download it anyway. Perhaps I'm better at writing than at speaking. Who knows? Okay, let me come to a conclusion. Well, we've seen module federation comes with several baked-in strategies for version mismatches. However, the best strategy is to avoid it upfront, and that's why lots of people out there are restricting themselves by going with a mono repo. That means they have a one version policy, and so they cannot run into version conflicts at runtime. However, also going with different repositories is possible. It has just different consequences. We've also seen there is this Webpack Runtime API allowing us to configure Webpack module federation at runtime, and so we can load something we did not know about at compilation time. And in the ending, we saw that if you really need it, and if you want to leave the nice road, if you want to enter the rocky road, you can implement a Frankenstein, you can bootstrap several single-page applications. And that's it. So thanks for having me, and have a nice day.